Good morning, students. Happy to meet you again. Today, we will be examining Pythagoras' theorem, and more specifically, we will be looking at right-angled triangle, the right-angled triangle, and Pythagoras' theorem. We are going to proceed in this manner. We will try to understand what a right-angled triangle is, after which we will name the sides of the right-angled triangle. Then we will state Pythagoras' theorem, and finally we will look at some application exercise, and take-home exercise will be given. So when we study different shapes and their length and angle, it is in that part of mathematics which is called geometry. So the study of shapes and their length and angles is very important. That's what we call plane figures. Then Pythagoras' theorem deals with special properties of the sides of a right-angled triangle, and that's why we linked the right-angled triangle with Pythagoras' theorem. So let's understand what a right-angled triangle is. A right-angled triangle is a triangle in which one angle is equal to 90 degrees. So you have a triangle and you can identify one of its angles as 90 degrees, then it is a right-angled triangle. So we saw that the symbol for right angle is this square. Once you have this on a triangle, it is a right-angled triangle. And because some of the internal angles of a right-angled triangle is 180 degrees, if this is already 90, then the remaining two angles should add to 90 degrees. So in a right-angled triangle, these other two sides, which are not right angles, will add up to 90 degrees. You take special note of that. So I said because all angles of a triangle add up to 180 degrees, the sum of the remaining two angles will also be 90 degrees. We now go to naming of the sides of a right-angled triangle. The side of a right-angled triangle which does not touch the right angle is called the hypotenuse. This is the right angle. These are the sides of the triangle. And we have said the side that does not touch the right angle is called the hypotenuse. Therefore, this side is what is called the hypotenuse. So you look at it, you will see that the hypotenuse will therefore be the longest side of a right angled triangle. The other sides are sometimes called the legs of the right angled triangle. And we could describe the other two sides. This one is called the hypotenuse. You call this with respect to these other angles which are not 90 degrees. And with respect to angle A, this side AB is described as the adjacent side with respect to this angle. Adjacent means next to. So AB is adjacent to A, and then BC BC is opposite angle A. So does it here? With respect to angle A, AB is the adjacent side and BC is the opposite side. Then with respect to C, BC will be the adjacent side. It's next to C. And AB will be the opposite. So this is it. With respect to C, AB is the opposite side and BC the adjacent side. We go now to present Pythagoras theorem. So what is Pythagoras theorem? Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the two shorter sides. So this is the hypotenuse AC. So we can state Pythagoras theorem by saying AC squared, that's the hypotenuse squared, equals AB squared plus BC squared. The square of the hypotenuse is equal to the sum of the squares of the other two shorter sides. So AC squared equals AB squared plus BC squared. That's Pythagoras theorem. We apply it. So you are given a right angle triangle and two of the sides are given. You could be tested on Pythagoras theorem by asking you to find the unknown side. So application, what is the value of the unknown side of the triangle below? This is a triangle. AB is 3, BC is 4. So we go back to Pythagoras theorem, which says the square of the hypotenuse equals the square of the sum of the squares of the other two sides. So we can state it, AC squared equals AB squared plus BC squared. We don't know AC squared, but we know AB. So AB is 3, so 3 squared plus BC, which is 4 squared, should give you AC squared. So AC squared equals 3 squared, which is 9, plus 4 squared, which is 16. AC squared equals 9 plus 16, which is 25. And to arrive at AC, take the square root of 25, positive square root, and the answer is 5. So we have determined the unknown side by applying Pythagoras theorem. We move to the next application exercise. Find x in the triangle below. This is a triangle, and again the triangle indicates there is a right angle from this. Once you notice this square here, you should know that the triangle is a right angle triangle, and you can apply Pythagoras theorem. So from Pythagoras theorem, the side opposite the right angle squared equals the sum of the squares of the other two sides. So 10 squared, which is the hypotenuse, should equal 6 squared plus the unknown side, which is x squared. 10 squared is 100. 6 squared is 36. We don't know x squared. We bring it down. We could now isolate x squared. by subtracting 36 from each sign. So you have 100 minus 36 will equal to 36 plus x squared minus 36, and what you'll be left with is x squared. So 100 minus 36 leaves you with 64. So 64 equals x squared. If x squared equals 64, then x is an error. X should be the square root of 64. And x is an error. X should equal 8 centimeters. So you correct these errors. This x squared was 64, therefore it should be x equal square root of 64, and x equals 8. So you will go back to Pressbook Secondary Mathematics and you will practice the use of Pythagoras theorem with exercise 13.2. You will find that on page 208. Remember to do the exercise with a lot of care so that you don't make a lot of errors. Thank you for listening. Do the exercise very well, and we will meet again next week.